Okay, so here's the spreadsheet from the Grape data that we collected. All 4 sets from Sauv Blanc, Montepulciano, Cabernet and Merlot. And in assignment 2, we put together some descriptive statistics for these data sets. And I've summarized them for us down here in this area there. I've separated the 4 varieties, shortened their name in most cases. I've put bin number in this left-hand column, and then I've got the average reading from the top and then the bottom of each bin for each variety. So, for example, here I have the average of these 3 readings taken in the top of the first Sauv Blanc bin, and down here is the corresponding average for these 3 measurements here, the bottom of the first Sauv Blanc bin. Now I've done that rather than to derive an average pH for the top of the bins of Sauv Blanc, Montepulciano, Cabernet and Merlot. I haven't just taken an average like this, which would give us the same answer, like so, and I'll just bring it down to 1 decimal place, 3.1. I haven't done that because I need the averages from the top of each bin to do the standard deviation. So I explained in the tutorial, we don't want to do the standard deviation of all of these numbers here because it will inflate that number. Instead, we're just going to use these little averages, the average for each bin instead. So I've calculated the standard deviation of all of the measurements for each bin, the average from each bin. So this is simply equals stdev. Then I've selected those cells there. So the average difference of each data point and the mean is 0.02. Just a reminder of the definition of the standard deviation. Now these are the descriptive statistics we required for assignment 2. And then in assignment 3, all we want to do is add some inferential statistics to our assignment 2. So we're expanding on our assignment 2 and making it a little more informative. And we're going to do t-tests. So they're the tests we use for comparing 2 means. And we learned how to do them 2 different ways. First of all, we look at the difference between the 2 means, find a confidence interval where we think the true mean difference is, and if that confidence interval includes 0, then we say they're not significantly different. If it does include 0, we say they are significantly different. That's one way of doing it, and we'll see how that can be done. But the simplest way is just using the t-test formula in Microsoft Excel. And I've done that over here. I've done a t-test comparing the bottom of and the top of each variety. Let's look at Sauv Blanc, and this gives us a p-value. So first of all, I do the formulas for Sauv Blanc equals t-test, telling Excel we want to do a t-test, and then I ask for the 2 arrays of data. So I've simply selected array 1 as the 5 measurements for the top of the bin, and then the second array, the 5 measurements in the bottom of the bin. Then it asks the number of tails. So the number of tails is asking, do we care if one mean is greater than or lower than, so it's just different than, or are we just asking the question, is the bottom of the bin have a higher pH than the top of the bin, or does the bottom of the bin have a lower pH than the top of the bin? Those 2 final questions would be one-tailed test, because we only care about one end of the distribution. When we're just asking, are they different, that's called a 2-tail test, because we don't care if one mean is right to the left on the distribution or right on the far right. We just care that they're significantly different. So it's a two-tailed test. So anytime you're doing a t-test where it's not asking for specifically is one mean greater than or one mean less than the other one, it's a two-tailed test. So that's represented by the 2 there. And then the type, if I just take that away, it'll give us the options. We just have 3 options for the type of t-test. The first one is paired. Are each of the data points paired? The second and third are when they're not paired, and we'll only ever use 3. 2 sample tests where there's unequal variance. So we only ever use 1 or 3. In this case we have paired data because we've got the top of, we're directly comparing the top of one bin with the bottom of that bin. So this is a paired test. So I type in a 1 there, press enter, and it gives us the p-value, the p being the probability the means are not different. Another way of looking at p is the probability of accepting the null hypothesis. When we're doing hypothesis testing, see the notes in topic 9. So a p-value, one way of looking at it, is the probability of accepting the null hypothesis. Another way, and so that's one definition of the p-value. Another definition, equally, if we don't talk about it in terms of hypothesis testing, one way of cutting to the chase is it's the probability that the means are the same or they're not different. So the probability that the pH from the top of the bins is the same as the bottom of the bins is 63%. 0.631709 or 63%. If the probability is greater than 5%, we say they're not significantly different. That's if we're interested in 95% confidence. If we're interested in 99% confidence, if the p-value is bigger than 0.01 or 1%, then we say they're not significantly different. If the p-value is less than 0.05 or less than 0.01, we say they're significantly different with 95% confidence, or they're significantly different at 99% confidence. So the Savant blancs based on this t-test are not significantly different because the p-value is greater than 0.05. On the other hand, Montepulciano, the p-value is less than 0.05. So we are 95% confident that they are significantly different. In fact, we're even more confident than that. We're less than 0.01 or 1%. There's 1% probability that those means are actually the same, or we're 99%, greater than 99% confident that they're different. Cabernet is almost 0.05, but it's not 0.05, it's greater than. So they're nearly significantly different, but they're not. And Merlot, the p-value is, well, let's get rid of some of these decimal places. The p-value is 0.2. So they are significant. They're not significantly different. We would accept the null hypothesis that the top of the bin equals the bottom of the bin. So talking about it in hypothesis terms, our null hypothesis, no difference in the pH from the top and the bottom. The alternate hypothesis, there is a difference in the pH from the top and the bottom. So we'd accept the null hypothesis for all these t-tests, except for all these hypothesis tests, except that Montepulciano. So that's the only one where there's a significant difference here. So that's a very simple way of doing it, the t-test strategy. Another way we could do it is by doing confidence intervals for the difference. So what is the true mean difference between each top and bottom measurement? We do this as per topic 7, where we find the difference between the top and the bottom for each paired measurement. So Here I've simply gone H18, the top, minus its corresponding other value, 3.8, and so on and so forth for all four measurements for Montepulciano, and I've done the same for Sauv Blanc. And then when we average those, we get the average difference between the top and the bottom. So in Montepulciano, on average, the top has a pH 0.05 greater than the bottom. The standard deviation of those is 0.01. Then we can do the confidence level using the formula x bar plus a margin of error and x bar minus the margin being the t value times the standard error being the standard deviation of the sample divided by the square root of the sample size. T we get from a table, and we look at find the degrees of freedom, which is the sample size minus 1. So in the case of Montepulciano, it's 4 minus 1, which is 3. We go to the table, find 3 on the T table, then move across till we find the column with our desired confidence level, which in this case we'll say is 95%, and that would give us a T value of 3.182. Then our margin is simply T times the standard deviation, which is 0.01, divided by the square root of the sample size, which is 4, which gives us 0.02. Therefore, we're 95% sure that the true mean difference between the top and the bottom of the Montepulciano bin is 0.05 plus or minus 0.02, which is 0.07 to 0.03. Because that doesn't include 0, we say they're significantly different. I've done the same procedure for Sauvignon Blanc, and in this case the confidence interval does include 0 because it goes from 0.03 down to negative 0.04. Therefore we say they're significantly different. So in our assignment 3, all you need to do is add the results for the t-tests and then some discussion about those results. So despite the fact that there was a difference in the pH between the top and the bottom of the bins in Cabernet and Merlot, it is not a significant difference. Only Montepulciano has a significantly different pH at the top and the bottom.